Yes, sir. So can I start with the intro?
Yes, yes, sure.
A very good afternoon to one and all present here. Today we have a guest speaker of the day, Irfan sir. We welcome you, sir.
Thank you.
Uh, about sir, sir has done his BE in Electrical Engineering from Nagpur University, his MTech in Electrical Engineering from IIT Roorkee, India. He has done his PhD in Electrical Engineering from VNIT Nagpur. He has qualified in GATE in 2002 with 97.70 percentile and All India rank of 273. An overall band score of 7.5 in IELTS appeared in January 2010. Sir has been working as a lecturer in Electrical Engineering Department of Anjuman College in 2004 to 10. In 10 to 11, he was a senior lecturer, and from then, in 2015, he was an assistant professor in Electrical Engineering Department of Anjuman College of Engineering and Technology. He's currently working in NIT Durgapur. We are glad to have you with us, sir. We
Thank
will
you.
start with the session, sir.
Okay. So there is a marked decrease in the enthusiasm level, I think, of the students as compared to the previous lecture. That I am going to be, I'm going to present my screen, so I won't be able to see your responses. Okay, so I need someone, when I ask a question, someone has to take the responsibility to answer. Who will take that responsibility? Who will take that responsibility when I ask a question? Not a technical question, general question like can you hear me or not? Can you see the screen or not? Somebody has to take the responsibility.
Sir, may I take?
Okay. Your name is Vaishali.
Yes, sir.
Okay. Okay. So I'm presenting my screen now. Okay. Okay. Before we start that, let me tell you that signals and systems, or let me ask you how many of you have studied signals and systems in your syllabus? Do you have signals and systems or digital signal processing? Vaishali?
So we didn't study, but specifically subject was not named as signal and system. But we have knowledge
The
of it.
topics you have studied
Sir,
in some
we
other
studied
subject.
topics, but there was not a particular subject. We are yet to come about.
Okay. So actually, generally in all universities now, electrical engineering, you have a subject on DSP, which covers the syllabus of signals and systems also. But Nagpur University has not done that till now. I think they should. In the future, they should. Okay, anyway, because you have not studied signals and systems, I have changed my approach in this class as compared to the one in power electronics. I am not covering the questions. I am going through the basics today. Okay. So I'm starting now.
Yes, sir.
Okay, Vaishali, can you see the screen?
Yes, sir. It's clear and
Okay. Signals and systems. Okay. This is the syllabus of signals and systems as per your GATE. When we were studying, when I appeared for GATE, signals and systems was not there. It was there in engineering services, but not in GATE. But now, of course, it has been included. This is the syllabus. Some topics you have studied, such as Laplace transform and Z transform, you studied in mathematics. Fourier
yes.
series representation of continuous periodic signals also you studied in mathematics in the first year itself. Linear time invariant and causal systems, I don't know whether you have studied or not. You saw the term linear time invariant in control systems, but you have seen till now. Sampling theorem studied in LEC, LIC.
LIC, we don't have a subject like that. Matlab, till now we didn't study.
Okay. Fourier transforms also you have studied in maths, but you might have skipped it. I don't know.
So no, might be in M3 or M4 we have that Fourier series.
Fourier series is different and Fourier transform is different. Lot of things in Fourier. 4 types of transforms are there. Yeah, anyway, so let us start with the basics. Okay, interactive session. First of all, what is a signal? How many of you know what is a signal? Can anyone answer?
A connection between transmitter and receiver, maybe.
Yes. So you are transmitting something, and you are receiving that thing. And that thing is called a signal. And why you are transmitting it? Because it contains some information. So broadly speaking, a signal is something which represents some information. They may be electrical, they may be mechanical, they may be thermal, etc. We see a lot of signals. For example, speech is a signal. Right now, as I am speaking to you and you are hearing it, my speech is being transmitted to you and you are hearing it. So that my speech, whatever I am speaking, that is being transmitted in the form of a signal. There can be speech signal, audio signal, video signals, images are also sort of a signal because they also contain some information. We have electrical signals also. For example, when we are taking the speed feedback of a motor, that speed is being fed back to a microcontroller. So that speed is also transmitted in the form of a signal. Classification of signals: continuous, discrete time, and digital. Okay. So someone apart from Vaishali, can anyone tell me what is a continuous signal? No one? Continuous signal? Okay. If you are serious in preparing for GATE, I think you have to study signals and systems because the questions in this subject can go up to 10 marks. Second thing, it is relatively easier as compared to the other subjects, even though you have not studied it before. Even with a slight hard work, you can score or you can cover the syllabus of signals and systems. For machines, if you want to score 10 marks, you have to study a lot. But in signals and systems, the syllabus is very small and the weightage is quite large as compared to the syllabus. Okay, so you have to study signals and systems if you want to score in GATE. These are the 3 types of signals. The first one is a continuous signal. A continuous signal is one which is specified at every value of its independent variable. Generally, the independent variable is time. So the continuous signal is denoted as x of t, small x as a function of t, small t again, time. So if time is the independent variable, a continuous signal means that its value is specified at every instant of time. The value may be 0, it may be non-zero, but it is specified. You know that at t is equal to 2.5 seconds, the value of the signal is this much. At t is equal to 2.6 seconds, the value of the signal is this much. So continuous signal will be specified at every value of its independent variable. The second type of signal is a discrete time signal, which is specified only at discrete values of its independent variable. Now the independent variable is a number. It is denoted as you can see my cursor, it is denoted as x as a function of n, where n is an integer now. It is not time. Basically, this n is equal to nts. The ts is suppressed. Okay, we don't write ts, but x of n corresponds to x at nts, where ts is the sampling time or sampling period, the reciprocal of the sampling frequency. So a discrete time signal is specified only at discrete values of its independent variable. I'll show you an example of a discrete time system. A discrete time signal. So regarding the books, there is one book on signals and systems by B.P. Lathi. B for boy, E for parrot, L-A-T-H-I, B.P. Lathi. That is one of the easier, simpler language books that is quite up to the standard. Okay, then there is one advanced book on signals and systems by Sundar Rajan. Okay, that is a very good book. If you have finished B.P. Lathi, you can go for Sundar Rajan also. This one today I am teaching from ProKIS. It is actually a DSP book, Digital Signal Processing book by PROAKIS, ProKIS. Because I am teaching DSP here at NIT Durgapur, I follow this book here. Okay, so Vaishali, can you see the signal?
Yes, sir.
This is an example of a discrete time signal. Let us say this value is 1. Okay. So on the independent variable, you can see the independent variable is n and the dependent
Yes, sir.
variable is x as a function of n. So when n is equal to 0, the value of x of n is 1. When n is 1, the value of x of n is 1. When n is 2, it is again 1, and so on. So
Yes,
the
sir.
question is, what is the value of x of n when n is equal to 2.5? Can anyone tell me? At n is equal to 2.5, what is the value of x of n? The answer is that it is not specified. It is not 0. Okay? When n is 2.5, the value of x of n is not specified.
Specified.
So this is what is called a discrete time signal. Its value is available only at discrete or specific instance of time. However, there is no limit on the independent value. The independent value can be anything. It can be 1, it can be 5 by 6, 1 by 2, 1 by 4, minus 1 by 2. The independent value, sorry, the dependent value can be anything. If you put a limit on the dependent value also, for example, if you say that the independent variable can be either 0 or 1 only, then that signal becomes a digital signal. Okay. So a digital signal is a discrete time, discrete valued signal. If you say that the dependent variable can only have values 0, 1, 2, 3, 4, 5, 6, 7, then that is a digital signal. Okay, is this clear? Everyone, what is a continuous signal, what is a discrete time signal, and what is a digital signal?
Yes, sir.
Did you know all this already? पहले से पता था ये? हाँ या नहीं?
यस सर, मतलब हाँ, सिग्नल्स मतलब कितने टाइप्स के सिग्नल्स होते हैं, वी वर नोन टू इट, वी वर ऑलरेडी फैमिलियर टू इट, बिकॉज मतलब जब हम स्टडी करते हैं सब्जेक्ट तो ये सब चीजें बेसिक है, तो
जब सिग्नल एंड सिस्टम स्टडी किए तब, है ना? और कोई सब्जेक्ट में भी आया था
यस
ये।
सर.
सिग्नल एंड सिस्टम्स में या और कोई सब्जेक्ट में भी ये आया था?
सिस्टम में नहीं, बट जो हमने सब्जेक्ट पढ़ा था यूपी एंड पॉली में जो माइक्रो प्रोसेसर था उसमें आया था।
ठीक है, ओके। नेक्स्ट we come to classification of signals. So one classification is periodic and aperiodic signals. I think this also most of you must know. For
No, sir.
continuous time, especially ये पता है नहीं पता है?
Periodic and aperiodic signals नहीं आया, but we know about cosine waves and sine waves.
So any discrete time signal that satisfies the condition x of small n plus capital N is equal to x of n for all values of small n is said to be periodic in nature. Sine and cosine waves, of course, are periodic in continuous time. In discrete time, it is possible that sine wave is not periodic. ठीक है, ये तो possible है. Discrete time में हमेशा sine और cosine wave periodic रहे ऐसा जरूरी नहीं है. ठीक है, we'll see it later. So let us say we have a signal from minus infinity to plus infinity और उसमें तीन values बार-बार repeat हो रही हैं. 1 2 3 1 2 3 1 2 3 continuously three values are repeating. So then we can say that that signal is a periodic signal because x at 4 will be same as x at 0, x at 5 will be same as x at 1, x at 6 will be same as x at 2, and so on. The smallest value of capital N that satisfies this condition is called the magnitude of the signal. So cosine waves, sine waves, complex exponentials are examples of periodic signals. Okay, we will see this later. A constant signal is also periodic with any period. In Fourier analysis, it is considered as a cos omega n or a e to the power j omega n with the frequency omega is equal to 0. If a signal does not satisfy the above condition, or if the period of a periodic signal approaches infinity, it is said to be aperiodic. So is this clear? What is a periodic signal? What is an aperiodic signal? Clear hai?
Yes.
Second classification, energy signal and power signal. ये भी पढ़े हैं पहले?
No, sir.
What is an energy signal and what is a power signal? Electrical engineering. In electrical engineering, we have seen that if the current flowing through a resistance is I, then the power dissipated in that resistance is I square R, and energy is integral of that power over a period of time. Similarly, for discrete time signals also, the energy is a square function defined as E is equal to summation n is equal to minus infinity to plus infinity magnitude of x of n whole square. Because there is a square term, the energy, because there is a square of the magnitude, the energy is always going to be positive. If a signal, and if you find the energy of a signal and you find that the signal energy is finite, then that signal is called an energy signal. Is this clear? What is an energy signal? A signal whose energy is finite, that is called an energy signal. Periodic signals can never be energy signals because they will have infinite energy. And periodic signals go from minus infinity to plus infinity. If you find out the magnitude at every instant, square it and add all such squares, the answer will always be infinite. That is why periodic signals are never energy signals. Only aperiodic signals will have finite energy and then they are called as energy signals. Okay? If the signal energy is infinite, if the signal energy is finite, it is called an energy signal. If the signal energy is infinite, then we find the average power of the signal. The average power is defined as limit n tends to infinity 1 upon 2n plus 1 summation n is equal to minus n to plus n magnitude of x of n whole square. Means you are finding the power over one cycle, where one cycle is going from minus n to plus n. Okay? That is why the limit is 2n plus 1 because of the 0, n is equal to 0. Okay? So if you find limit n tends to infinity 1 upon 2n plus 1 summation n is equal to minus n to plus n magnitude of x of n whole square, what you get is the average power. If the average power is finite, then the signal is called a power signal. Sine waves, cosine waves are power signals. They are not energy signals. So to recalculate, if the signal energy is finite, it is called an energy signal. If it is infinite, we find the power. If the average power is finite, the signal is called a power signal. If the average power is also infinite, then the signal is neither an energy signal nor a power signal. Okay? You will need practice in this subject. You will have to take some signals and practice how to find their energy and how to find their average power. Okay, so that BP Dati book will have a lot of solved examples so that you can learn how to find the energy of a signal and the power of a signal. Next is even symmetric and odd symmetric signals. A signal is called even symmetric if x of minus n is equal to x of n for all values of n. मतलब कि n is equal to 2 पर जो value है वही value n is equal to minus 2 पर है. Whatever value is at n is equal to 1, the same value is at n is equal to minus 1 and so on. If this condition is satisfied, we say that the signal is an even symmetric signal. For example, this is an even symmetric signal. This is the n is equal to 0 line. So whatever is the value at n is equal to 1, the same value at n is equal to minus 1. N is equal to 2, n is equal to minus 2. 3, minus 3, 4, minus 4, and so on. So the cosine signal is an even symmetric signal. A signal is said to be odd symmetric if x of minus n is equal to minus x of n for all n. Here, for an odd symmetric signal, it is essential that x of 0 must be equal to 0. This is an example of an odd symmetric signal. This is the n is equal to 0 line. Whatever is the value at n is equal to 1, its negative is the value at n is equal to minus 1. The value at n is equal to 2 is the negative of the value at n is equal to minus 2. So this one is an even symmetric signal or even signal, and this is an odd symmetric signal or odd signal. Next is causal and non-causal signals. So a signal x of n is said to be causal if x of n is equal to 0 or n less than 0. And if x of n is not 0 or n less than 0, the signal is said to be non-causal. Okay? So a causal signal simply means that all of its values will be 0 for n less than 0. These signals that you see, they are having values for n less than 0 also. That is why these are non-causal signals. However, if this signal had started from n is equal to 0 and all previous values had been 0, then it would be called a causal signal. Okay, this clear? Are you able to follow me or not?
So,
Remaining students, वैशाली के अलावा और उस्मान,
Yes, sir.
are you able to follow me
Yes, sir.
or am I going too fast?
No, no, sir. It's a correct pace.
here I have shown some examples of some signals. You see this signal? This is called a unit impulse signal, del of n. It has only one value at n is equal to 0. All values of this signal for n less than 0 are 0. That is why this is a causal signal. This signal that you see, this is a unit step signal. Again, it is starting at n is equal to 0. And for all values of n greater than 0, its value is 1. For all values of n less than 0, its value is 0. This is also a causal signal. This is called a unit ramp signal. For all values of n greater than or equal to 0, its value is non-zero, whereas for all n less than 0, its value is 0. This is also a causal signal. These are non-causal signals because they have non-zero values for n less than 0. Next is deterministic and random signals. Suppose you have a signal such as x of n is equal to sine 5n. You can find out the value of x of n for all values of n. Such signals are known as deterministic signals. Signals such as the speech signal, whose future values are not exactly known. For example, if you are plotting my speech signal, you do not know what will come after 1 minute. Such signals are known as random signals. So you won't be having random signals in your syllabus. You will only have deterministic signals. Now that we've seen the classification of signals, let us see some basic signals. You know these basic signals we have studied in control systems for continuous time systems. They are more or less similar for the discrete time systems also. For example, the first signal is the unit impulse signal, defined as del of n is equal to 1 for n is equal to 0 and 0 for n not equal to 0. And we just saw this is the unit impulse signal. Del of n is equal to 1 for n equal to 0 and it is non-zero for n not equal to 0. Next basic signal is the unit step signal. The unit step signal is defined as u of n is equal to 1 for n greater than or equal to 0 and it is 0 for n less than 0. Again, this is the unit step signal. Its value is 1 for all values of n greater than or equal to 0 and it is 0 for all values of n less than 0. You have the ramp signal also, but you will rarely use the ramp signal, so I have skipped that and have jumped directly to sinusoids and exponentials. Now we have seen continuous time sine waves. In electrical engineering, we are always dealing with sine waves. The discrete time sinusoid is expressed as x of n is equal to a cos omega n plus theta, where capital A is the amplitude of the sinusoid. Omega is the angular frequency. The unit of omega in continuous time it was radian per second. In discrete time it is radians per sample. And theta is the phase in radian. A frequency f, omega upon 2 pi. Continuous time the unit is hertz or cycles per second. In discrete time it is cycles per sample. And we don't have time in this lecture to prove this, but a discrete time signal is periodic if and only if small f is a rational number. All discrete time signals, all sine waves that we encounter in signals and systems will not be periodic. There is a condition for periodicity, and the condition is that the frequency small f should be a rational number. That means it must be a ratio of 2 integers. Suppose the frequency is pi by 3. Suppose this frequency comes out to be pi by 3. Then the resulting sinusoid is non-periodic because f is not a rational number. However, if the frequency is, let us say, 4 by 7, then the resulting signal is a periodic signal. and the denominator of this small f, that will be equal to your fundamental period. Okay? Remember this. The denominator of the small f will be equal to your fundamental period. So here I have drawn I've shown a discrete time sinusoidal signal defined as x of n is equal to a cos omega n plus theta. This a is the amplitude of the sine wave that corresponds to the maximum value of the sine wave. This is an example where a is constant. You can have examples where a can be increasing or decreasing also. Okay, we will not concern ourselves with those signals here. So this is an example of a signal where a is constant. Now, what is the value of omega in this case? Can anyone tell me? What is the value of omega in this case? Study the signal. Tell me what is the value of omega, what is the value of f, and what is the value of theta. Yes, anyone? Okay, let us find the value of omega. Okay. For that, we need to identify one cycle of this discrete time signal. If we are starting from here, one sample, second sample, third sample, fourth sample, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. Here the cycle is completing. So there are 12 samples in one cycle. Vaishali, can you, when I'm moving my cursor, is it visible on the screen?
Yes, sir. Sir,
Yes, you have any question?
yes, sir. Sir, you said कि we have 12 samples, but आप ये last वाला count नहीं किया?
ये एक मिनट, यहाँ से स्टार्ट किए. ये हुआ फर्स्ट सैंपल, सेकंड, थर्ड, फोर्थ, फिफ्थ, सिक्स्थ, seventh, eighth, ninth, 10th, 11th, 12th. Here the cycle is completing. We had started from here, but it is completing here.
Okay.
You know, if we start from this 0, then first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th. Once again, we are coming back to 0. So one cycle starts here and it is ending here. So there are 12 samples in one cycle. Okay, now it is clear?
Yes, sir.
Now one cycle corresponds to 2 pi radians. So in 2 pi radians, there are 12 samples. So how many radians per sample? It is 2 pi divided by 12. Radians per sample, 2 pi radians, 12 samples. So radians per sample is 2 pi divided by 12 or pi by 6. So the angular frequency of this signal is pi by 6 radians per sample. Is this clear, everyone? Yes or no? एक साइकिल में 2 पाई और सैंपल्स कितने 12. तो एक सैंपल में कितने रेडियन हो गए 2 पाई डिवाइडेड बाय 12 और पाई बाय 6 रेडियंस पर सैंपल. ठीक है, दैट इज द एंगुलर फ्रीक्वेंसी ऑफ दिस सिग्नल. Now the cyclic frequency small f, that will be equal to omega divided by 2 pi. Omega is pi by 6 divided by 2 pi. pi and pi will get cancelled. So the frequency becomes 1 by 12 cycles per sample. Okay. The frequency f is 1 by 12 cycles per sample. Okay. I will send this PPT to Shafiq sir. You watch it closely and you confirm. Okay. So right now you can simply write it down. Omega is pi by 6 radians per sample, and the cyclic frequency is 1 by 12 cycles per sample. Okay, omega divided by 2 pi. Now, because the frequency f is a rational number, and it is the ratio of two integers, 1 upon 12, that is why this signal is periodic. And its fundamental frequency is the denominator of f, that is 12 samples. Okay, can anyone tell me what is the value of theta here? Theta. This is the value of A. Omega, we have seen it is pi by 6. The frequency small f is 1 by 12. One cycle has 12 samples. But what is the value of theta here? This sample, if it had appeared here, then the value of theta would have been 0. And a cosine signal, not a sine signal. So if this sample had appeared here, the value of theta would have been 0. But this sample has been advanced by 2. This value has been advanced by 2 samples. तो कितने रेडियन हो गए? कितने रेडियन हो गए? How many radians? एक सैंपल में कितने रेडियन है? ये कितना रेडियन है ये वाला? एक सैंपल ये है पाई बाय 6. अभी निकाले थे हमने पाई बाय 6 रेडियंस पर सैंपल ओमेगा. So this is pi by 6. So this becomes pi by 6 plus pi by 6, that is pi by 3. So the value of theta here is pi by 3 radian. ठीक है? Is this clear?
थोड़ा थोड़ा
थोड़ा ही ये hard, it is not easy. I'm not saying it is easy, it is hard. If in today's class 0 से थोड़ा ऊपर मैं लेके आ जाऊं तुम लोगों को तो ये भी काफी है. ठीक है? The next time that we study, because when you will start studying signals and systems, these things will come first. ठीक है? जब बुक खोलेंगे तो यही सब चीजें दिखेंगी. ठीक है? तो तब अगर थोड़ा पढ़ने में मदद मिल जाती है तो ही ये काफी है. ठीक है? क्वेश्चंस अगर मैं दिखाऊंगा, अगर मैं आज क्वेश्चन सॉल्व करने बैठ जाता तो you would never have studied signals and systems again. ठीक है? Questions are very very hard. सर पैर तक नहीं मिलेगा. मैं एक क्वेश्चन दिखा देता हूँ. Can you see? ये है जैसे 2018 का क्वेश्चन. Let f be a real valued function of a real variable defined as f of x is equal to x squared for x greater than or equal to 0 and f of x is equal to minus x squared for x less than 0. Which one of the following statements is true? देखिए थोड़ा सा आसान है. कौन सा स्टेटमेंट ट्रू है? कैसा है? फंक्शन कैसा है, एफ ऑफ एक्स इज इक्वल टू एक्स स्क्वायर्ड फॉर एक्स ग्रेटर देन और इक्वल टू 0। तो जब x की वैल्यू 0 है तो एफ ऑफ एक्स की वैल्यू भी 0, x की वैल्यू 1 तो एफ ऑफ एक्स की वैल्यू 1, x की वैल्यू 2 तो एफ ऑफ एक्स की वैल्यू 4। मतलब पॉजिटिव साइड में पैराबोलिक है और नेगेटिव साइड में भी पैराबोलिक है। तो क्या है फंक्शन, डिसकंटिन्यूअस है क्या? इज इट डिसकंटिन्यूअस एट x इज इक्वल टू 0? नो, इट इज कंटिन्यूअस। ठीक है, the right answer here is f of x is differentiable, but its first derivative is not differentiable at x is equal to 0. That is the answer of this question. ये है एनर्जी के ऊपर अभी जो हमने एनर्जी सीखे थे, एनर्जी सिग्नल एंड पावर सिग्नल, दो कंटिन्यूअस टाइम सिग्नल्स हैं, इनको सैंपल किए, सैम्पलिंग पीरियड ऑफ t is equal to 0.25 seconds, और डिस्क्रीट टाइम सिग्नल बनाए x1 of n एंड x2 of n। फिर एनर्जी के ऊपर है ये क्वेश्चन। ठीक है, तो ये क्वेश्चन अगर हम डायरेक्टली सॉल्व करने बैठेंगे, ये क्वेश्चन अगर हम डायरेक्टली सॉल्व करने बैठेंगे तो बहुत ज्यादा डर लगेगा और मेरे को नहीं लगता कि कुछ भी समझ में आएगा। ठीक है, दैट इज व्हाई बेसिक्स आई एम टीचिंग। आई हैव टोल्ड यू द नेम ऑफ द बुक। कौन सी बुक से पढ़ना है? डीपी लाठी से। ठीक है, so when you will open the book you will see whatever I am teaching today. ठीक है, so you will get a start। और बहुत सारे तो a lot of topics you have already studied, I think, like Laplace transform, that transform you have studied, Fourier transform, Fourier series also is easy। बस ये वाला जो part है this is slightly new to you, which can be covered when you study। ठीक है, and 10 marks, I told you it is almost 10 marks। ठीक है, so I'll return to the slides now। Once again I'll repeat, if you start from here, ठीक है, ये भी ऐसा हार्ड लग रहा है लेकिन इसके ऊपर if you give 15 minutes to this it will become very easy। If you start from here from 0 and you return back to 0, so this is one cycle। So in one cycle there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 12 samples in one cycle। Now one cycle always covers 2 pi radians। यहाँ से लेके यहाँ तक कितना है? 2 pi radians, और सैंपल्स कितने हैं? 12 है। तो फ्रीक्वेंसी कितनी हो गई? फ्रीक्वेंसी होती है, एंगुलर फ्रीक्वेंसी होती है इन रेडियंस पर सैंपल। तो इट विल बी सिंपली one cycle, that is 2 pi divided by 12, that is pi by 6 radians per sample। That means यहाँ से यहाँ गए तो pi by 6 radians, यहाँ से यहाँ गए तो pi by 6 radians, यहाँ से यहाँ गए तो pi by 6 radians, and so on। Cyclic frequency, cycles per sample, that can be found using omega upon 2 pi। ठीक है, if you find omega upon 2 pi, pi by 6 divided by 2 pi, that becomes 1 by 12 cycles per sample। Or in one cycle there are 12 samples। In one cycle there are 12 samples, so cycles per sample is simply 1 upon 12। okay। If this had been a pure cosine function, maximum value 0 पे आई होती, the maximum value would have come at 0। In that case the value of theta would be 0, but now the maximum value is coming slightly earlier। That means this signal is advanced, so theta has some value। What is the value of theta? 1 sample, 2 samples। ठीक है, एक सैंपल कितने रेडियंस है? pi by 6 है ना, pi by 6 रेडियंस पर सैंपल। तो 2 सैंपल कितना हो गया? pi by 6 plus pi by 6, that is pi by 3। So the value of theta is pi by 3। If you will advance this by pi, pi by 6 plus pi by 6 plus pi by 6 plus pi by 6 and so on. If you advance a cosine signal by pi, it will become a sinusoidal signal. So let us come to the next thing. Exponential signal. Continuous time, we have seen exponential signals. They are denoted as e to the power at, where a can be positive as well as negative. Correct? Yes or no?
Yes, sir.
In discrete time systems, exponential signal is defined as x of n is equal to a to the power n for all values of n. If a is real, okay, a can be complex also. I have not taken that part here. I have taken only when a is real. So if a is real, you can have four types of signals here. This is if the value of a is greater than 0 but less than 1. Okay. Then you will have a decreasing exponential. This is when the value of a is greater than 1. You have an increasing exponential. If the value of a lies between -1 and 0, you have alternate positive and negative values, but they are decreasing. And if a is less than -1, again alternate positive and negative values, but increasing. Okay, so this is an exponential signal in discrete time, defined as a to the power n. Okay. You take an example and you try and plot some signals. Suppose you take the value of a as 2, you get 2 to the power n. If n is equal to 0, x at 0 will be 2 to the power 0, that is 1. So a is greater than 1 here. So 2 to the power 0, that is 1. Let us say this is that value. Then n is equal to 1. X of 1 will be 2 to the power 1, that is 2. X of 2 will be 2 squared, that is 4. 2 cubed, that is 8, and so on. So it will increase exponentially. But if a is less than 1, suppose a is 0.5. So 0.5 to the power 0 is 1. 0.5 to the power 1 is 0.5. 0.5 squared is 0.25, and so on. So that will become a decreasing exponential. Okay. Are the basic signals clear? Unit impulse signal, only one value at n is equal to 0. All other values are 0. Unit step signal, signal value is 1 for all values of n greater than or equal to 0 and 0 for n less than 0. Sinusoids, x of n is equal to a cos omega n plus theta. A is the amplitude, omega is the angular frequency in radians per sample. Theta is the phase in radian. Cyclic frequency f is omega by 2 pi in cycles per sample. Discrete time signal is periodic only if small f is a rational number. And then these are the exponential signals. Let us take a 5-minute break here. And then we'll go to analog to digital conversion. Okay? 5-minute break. So it is 3 p.m. here. We'll start again at 8 p.m. Okay?
Yes, sir. you.